So today's notes is we're kind of compiling or bringing together all our different methods we use to solve quadratics. And we're going to start off today by talking about like the pros and cons of each method. And your learning target today is being able to decide for yourself which method is the most effective to use. So the methods that we learned so far this year, and all of this has happened in the last month and a half: factoring, graphing, using square roots, completing the square, and quadratic formula. We'll go down the list one by one and talk about the pros and cons of each, and when to use them and kind of when not to use them. So let's start with factoring. Factoring is when we would set up our x, find numbers that multiply to our top, add to our bottom number. We would write two pairs of factors. The advantage of that, it's pretty straightforward and we practice it a lot. A lot of you got really good at finding numbers that multiply, then add, and going through and factoring. The big disadvantage of that is that not everything can be factored. So factoring only works so much. It gets to a point where you can't use it anymore. Second method, graphing. We did this chapter where you would find like your vertex and some points, and you would see where it crosses your x-intercept, and that's where your solutions are. So a big pro of graphing is that you can easily see the number of solutions. So if it crosses your x-intercept twice, you know you have two solutions. If it just touches it once and bounces off, you have no solutions. And you know if it doesn't cross at all, you have no solutions. The disadvantages, well, a big one, if you don't have a coordinate plane on your paper, it's hard to graph. A lot of people, if you want to say people just don't like graphing, that's a big disadvantage. And then also, since you're doing it by hand, it's hard to get like exact solutions. You're going to do a lot of approximating. Using square roots was another one we did recently. So we use square roots to solve when we had like an x squared equal to a number, or whether we had a coefficient in front of our number, and we just took the square root of both sides. So we got x by itself. It would say x is equal to plus or minus whatever number we get. That works a lot if we always just have an x squared. One instance it would not work if we would have like an x squared and also an x term. So this can only be used for certain equations, and it's equations that only have x squared in it. Completing the square. If you notice the pattern, when we've done this, every time our a term has been 1 and our b term has been even. Completing the square is a good way to, it'll always work if you're good. Advantage of that, it's kind of the same steps each time, but that can also be a disadvantage. Or you may not like going through and doing those same steps all the time. Maybe you forget a step here and there. And again, it involves a lot of calculations. So a lot of stuff on your calculator, you got to make sure all your math facts are right. Last method, quadratic formula. The big pro, why this is good to use, is because it can solve any quadratic equation. No matter what you're given, if you plug it into your quadratic formula, you're going to get out your solutions. The con of it, as you saw yesterday, it's a lot of writing things down. It takes up a lot of space. You may not like that aspect. You may not like just the plugging in numbers and going. You may want a more efficient method. So that's where a disadvantage could be. So for these 4 examples on the bottom, what I'm going to do is I'm going to choose a different method for each. So you can see like each one in action. And then on your homework, if you just take a peek at it, your front side is you're using solving square roots, completing the square in quadratic formula. And then on the back side, you get to choose what you want to use. So we'll do example 1 first, 1A. To start, I see that I have an x squared term, an x term, and they're on the same side. And I just have a number on my other side. Other things, my a term is 1 and my b term is even. So one way I can do this is by completing the square. I want to stress that completing the square is not like the correct way to do it. It's just one way to solve. But that's the way I'm going to use completing the square. So I'm going to write my method that I choose off to the side. Complete the square. And this is from, so you can go back and look at your notes if you get stuck. It's from 9.4. So our steps for completing the square. We first would have to split up our b term, which is negative 10. We have to divide it by 2, then square it. So negative 10 divided by 2 is negative 5. And then we have to square negative 5. Excuse me. Negative 5 squared is 25. And that's the number to actually do our completing that we add to each side of our equal sign. So we would have x squared minus 10x. I'm going to write it in a different color because we're adding 25 to this side. And we're also adding 25 to our other side because we got to keep our equation balanced. Our steps for completing the square, we would then factor our left-hand side. So if you need to set up your x and you like that as a visual, go ahead and do that. Or you have your 25 on your top and your negative 10 on your bottom. And then you decide two numbers that multiply to the top but add to the bottom. One pattern, one thing you may have picked up on, if this bottom number is negative, your two numbers on the side will always be negative. If this number is positive, your two numbers on the side will always be positive. So to multiply to 25, we can take negative 5 and negative 5. That also adds to negative 10. So put negative 5 here, negative 5 here. And we can write this as a product of factors squared. We then take this, the numbers on either side, and we say this is x minus 5 squared is equal to, and we just simplify our right-hand side. 25 plus 1 is 26. From there, our steps are the same. We take the square root of both sides to get what's inside the parentheses by itself and get rid of the square. So we square root and square root. So this will be x minus 5 is equal to plus or minus the square root of 26. Why I leave it the square root of 26? If you look on your factor sheet, the only factors of 26 are 1 and 26 and 2 and 13. So none of those are perfect squares that we can evenly divide 26 by. So we leave it as a square root. And then to solve for x, we have to add 5 to both sides. That gives us x by itself. So we can show that step using our opposite operations. X is equal to 5 plus or minus the square root of 26. And now this is where your calculator comes in handy. You type in 5 plus square root of 26 and you're going to get one answer. Doing it correctly, you'd get 10.1 when you add the two. And then you take 5 minus square root of 26. And that gives you your second answer for x. So x is equal to negative 0.1 would be your other answer. So again, for quadratics, you can get two answers, one answer, or you get no solution. In this case, we have two answers. Yes, they get shorter. The first two are a little long. All right. Example B. Again, we're going to choose a different method to use. When I look at this, I see that my A term is 2, my B term is odd, so I'm not going to complete the square. I could try factoring this, but I don't want to use factoring by grouping. So I'm going to use my quadratic formula to solve this. Quadratic formula is the one that's always going to work. So that's kind of like, if you don't know where to start or what to use quadratic formula. And that was from section 9.5, what we did yesterday. So your quadratic formula, you're not going to have to memorize. I'll give it to you on the test. I'm going to write it off to the side here. I would copy it down. X is equal to negative b plus or minus b squared minus 4ac divided by 2 times a. So my big suggestion is always to label your a, b, and c terms so that it's a lot easier to plug in. Oh, because you were talking before.
I wasn't talking.
A is equal to 2, B is equal to negative 13, and your C is equal to negative 24. So we're plugging these values into our quadratic formula now. We'll say this is equal to the opposite. So remember, we changed the sign of our B, so it's negative. So we plug it in as a positive. So 13 plus or minus. We square 13, or negative 13. Minus 4 times A times C, so that's 4 times 2, and then times negative 24. So then it's divided by 2 times A, which is 2 times 2. And yesterday, we went through all of our steps, and we always simplified what was underneath the square root first before we touched anything else. We got this to be one number. So you can do that on your calculator. I'm going to do it by hand. This will be 13 plus or minus the square root. 13 squared is 169. 4 times 2 is 8. And then times negative 24. So 8 times negative 24 is negative 192. So this is minus negative 192 divided by 4. And I know we didn't talk about an example like this on the notes yesterday. It may have been on the homework. What you get when you multiply your 4 and your a, c together, you get a negative number. So if you're subtracting a negative number, that turns it into a chunky plus. Subtracting a negative is a chunky plus. So that's what we're going to turn this into, chunky plus.
What?
So that would give us, if we add those two together, we get 361. So we get 13 plus or minus square root of 361 over 4. And the square root of 361 is 19. Again, that's something you'd have to, if you don't know it right off the top of your head, you use your calculator to do. If you get to the point where you take the square root of a number and it's not a whole number, you just leave it underneath the square root. You could round it to a decimal place. That's fine. You just are, your answers may not be exact, or you may have some rounding error when you get to the end. Yeah. No, but most of the time, like if this is not a perfect square, you're going to get a long decimal, so you don't want to have to write like a long decimal each time. All right, so, gosh, I'm running out of space. I'm going to drop it just down below. This is 13 plus or minus 19 over 4. Because the square root of 361 is 19. Calculator, if you don't know. So then this is the part where we split it up into our two. We have to use one with the plus, one with the minus. 13 plus 19 divided by 4, and 13 minus 19 divided by 4. The most common mistake on this step is an order of operations thing. A lot of people want to take 13 divided by 4 and then add 19, which is incorrect. We have to add our top numbers together before we divide. Which means if you're doing this on a calculator, you're trying to do all of this in one step, you need to put your numerator in parentheses for your calculator to follow order of operations correctly. If you're not good at remembering all those calculator rules, an easy workaround is just adding your top numbers first. So 13 plus 19 is 32. So 32 divided by 4 is 8. So then we get a final answer. And you do the same thing for the bottom. You can do 13 minus 19, which would be negative 6 over 4, which then you get negative 1.5. So again, we have two answers for x. And that's all by quadratic formula. So you can see, big advantage, we didn't know what to use. We used quadratic formula and ended up working. Disadvantage, a lot of steps, a lot of calculations.
What's 7 squared?
49.
49.
All right. So these last two examples they're going to be quicker because we're going to use most efficient method. So if you ever have 3 terms and your numbers are small enough, I would always check, see if you can factor it. See if you can set up an x. If I try to set up an x, I'm going to have a 12 on the top and 8 on the bottom. So two numbers that multiply to 12 and add to 8 are 6 and 2. And again, it doesn't matter which side I put them on, but it's going to work out, 6 and 2. And just like how we did in the first example, I can write this as a pair of 2 factors. X plus 6, and then also x plus 2 is equal to 0. And then we have to solve this. We have to get an answer out for x. So we have to go back to what we learned in Unit 7. Our ZPP, which stands for zero product property, which means we have to set each of these parentheses equal to 0 and solve. So we say x plus 6 is equal to 0, x plus 2 is equal to 0. So we can subtract 6 from both sides. So one of our answers is x is equal to negative 6. Other answer, we subtract 2 from both sides. So x is equal to negative 2. So this is something we haven't done recently. So this is all the way back from, this is all of Unit 7. Factoring and using zero product property. Yeah, zero product property. All right. Last example. This is a case, I look at this and I see all I have is an x squared term. In your equation, if all you have is x squared, you want to use square roots to solve. So you're going to try to get this x squared by itself. So we can do that in 2 steps. We can add 5 to both sides. Plus 5 and plus 5. So we have 9x squared is equal to 9. And then we're going to keep trying to get x squared by itself. So this is being multiplied together. So to undo multiplication, we can divide. We divide each side by 9. So we have x squared is equal to 1. And then we can simplify. Take the square root of both sides to get our final answer. X will be equal to plus or minus 1. Again, because we're taking the square root of a number, it's our positive answer or our negative answer.
Wait, the one that you circled, unit 7,
That's factoring, sorry. I actually didn't write it. Unit 7, factoring.
that was for problem C.
C. And then, so problem D was using square roots. And that was section 9.3. So on your homework, big thing, make sure you're reading directions. The front page, it tells you which method to use, and on the back page, you can use any method you want. On the back page, if you're really struggling with what to use, remember quadratic formula works for everything. So that can kind of be your backbone if you don't know what to do. Use quadratic formula.